Hi everyone, welcome back to Joe Microsphere, your hub for GIS and Remote Sensing tutorials. In today's video, I'm going to show you exactly how you can calculate for land surface temperature or LST using your Landsat Collection 2 Level 2 image. That's the surface reflectance data. And then if you are working on climate data, drought, agriculture, or any other urban heat island and the others, LST is one of the most powerful tools that you can use. So stay with me as I break everything down step by step for you. Alright, so to calculate for land surface temperature using your collection tool, there's a few steps that you need to go through before you can arrive with your actual LST in your degree Celsius. So the first thing that you need to do is you need to apply your scale factors before you get your LST in Kelvin, and then after getting that you convert your Kelvin to degrees Celsius. So let me show you why we use level 2 or why level 2 is mostly preferred. Alright, so level 2, this is the temperature definition. That's the land surface temperature definition. That's the earth surface as measured by a satellite, and then these are the major rules, and then we have the atmospheric correction. So why we use level 2 is the atmosphere is already corrected. It provides surface temperature, and then it includes cloud masking, and then level 1 give you the brightness temperature, doesn't give you the actual temperature. That's why we don't normally prefer the level 1. Okay, so we have our band 10 here. That's the thermal infrared band. That's what we are going to use to calculate for our LST. And then this is the scale factor I was talking about. And then after applying the scale factor, you get your temperature in Kelvin. After getting in Kelvin, you subtract your 273.15. that is the constant to get your LST in your degrees Celsius. So let's quickly get into it. So the first thing you need to do is you need to download your satellite image. After downloading it, you can go to your view, and then you choose your catalog, and then you add folder. So after adding folder, you connect your the folder of the satellite, and then you open the folder, and then you can see we have your band 10 here. So you click on it, and then you drag it to a table of content to add your band 10 here, and then after adding it, you can rename it. You can name it as BT underscore B10. Alright, so this represents our band 10 here. So after getting your band 10, what you need to do next is you need to go to your processing tool and then search for a raster calculator. That is the spatial analysis tool. So after getting your raster calculator, you are going to apply the scale factor to this one. So first of all, you need to double click on this one to add to your raster calculator dialog box. So we have our BT band 10 here, and then let's view our. So this is our scale factor here. So we can copy this, and then so you can see it's ST band 10 times. So this symbol represents times, and then 0.00341 plus this scale factor. So here we are just going to double click on our times symbol, and then paste our scale factor here. So you can see we have our band 10 times this plus this, and so here we can name it as LST underscore Kelvin. Then you click on run. So after running this one, what we are going to do next is you can see we have our LST in degrees Celsius. So after running for our Kelvin, we are going to subtract our 273.15 from our Kelvin to get our actual LST value. So you copy the scale factor here, and then you copy, so and then you go to your GIS Pro. So now this is our value for our LST Kelvin, which can see we have 3.72 to 2.75, which is not normal temperature, so we need to convert it to Kelvin to get our normal temperature. So to get that, you clear this one here, and then you add your LST Kelvin. So you add your LST Kelvin, and then you paste your constant here, so which you can see that's a minus 273.15 here, which you can see, and then you rename it as LST Celsius or degrees Celsius. Alright, so this is the LST which we just created, and then this is the constant value that we are subtracting from the LST Kelvin. Then you give it output name, then you run it. Alright, so now you can see we have our highest temperature of 99, then we have our lower temperature of 2.69. so the lowest temperature can be found on the where we have the water body. So when you look into this image, you can see under the image there, here are the sea. So here we can find the lowest temperature here. Then we have a river or a water body here where we can get a lower temperature there. So what you need to do next is you need to click to your study area. So if you are working with a certain study area, you can just click here, and then you locate to where you have saved your your shapefile. Alright, so go to where you have your shapefile. Alright, so here you can search and then choose your shapefile. So let me choose this shapefile here. Okay, let me change it. This one is alright, so let me try this one and see. No, this one too. So you look for a plain shapefile that does not contain any county or any district inside. So let me search and see if I will find a shapefile for that. Alright, so let me use this one. Alright, so this is my shapefile. Then what we are going to do next, we are going to clip the image to our study area, and then get the actual temperature value for our study area. So you search for clip, then you choose clip, that's the data management tool here, and then so your input feature is going to be your LST Celsius, and then your output is going to be your shapefile. Then you check on use input feature for clipping geometry, and then also maintaining clip extent. You can check it or you can leave it. It doesn't cause anything. So after inserting your input raster and your output raster, you need to run it, and then your final results will come. So you make, after running this one, you just have to make your gamma shape hollow so that you can see your map, and then uncheck the other layers. Alright, so now we can uncheck the other layers here to get our actual alright, so this is our actual temperature here. So just zoom into layer. So we have the highest temperature of 49.63, and then we have the lowest temperature of 16.74. so this one you can just click here, and then you change the color to your any color of your choice, or any color that you think it will represent your LST. So this is my LST here. As you can see, we have the highest temperature at this side, and then we have the lowest temperature at the southern parts. So this is how you calculate for your land surface temperature. So thank you for watching this complete tutorials on calculating land surface temperature using Landsat Collection 2 Level 2. If you enjoyed this video or learned something new, please support the channel by liking the video, leave a comment, subscribe to the Geomicrosphere, share the tutorial with your classmates or colleagues. If you want me to create tutorials on others or urban heat islands, just drop a comment. This is George from Geomicrosphere. See you in the next lesson. Thank you very much.